Hello everybody, this is Bruce at Groxio Learning. I've got Maggie behind the camera and I've got the dog on the floor. And today we're here to talk to you about OTP. This is the last language. It's not really a language per se. It's more of a programming model and it's OTP. We're going to talk a little bit about that today. Now OTP is a great way to manage things that need some process machinery. It was something created by Joe Armstrong and his team at Ericsson Labs. You might ask yourself, what does OTP stand for? And the answer is nothing. So once upon a time, it stood for Open Telecom Platform or something like that. But today, it's just an abstraction. It's an abstraction for building things with processes. You might call them services or servers. In fact, the thing that we'll be building with our OTP platform is a gen server or a generic server. Now, there's a couple of interesting innovations in OTP that we need to think about. The first is that when you're in a functional language, it's sometimes difficult to hold on to state. So the hard things become really easy, like reliability and managing failure. But some of the easy things, like managing state, become really hard because functional languages don't really know, or since they're immutable, it's hard to track changing state over time, and that's one of the things that OTP gives us. Well, how does it do it? Well, it uses a combination of concurrency, message passing, and recursion. And that's a weird thing to think about when you're just tracking a variable over time. But it's an interesting paradigm, so we'll stay with it. So the first interesting innovation is using this process loop to manage state. But the second one is also interesting. It's actually adding a level of indirection, a pointer, if you will, to build a service that is just responsible for managing the lifecycle. So we're actually building one generic server to solve a business problem, and one generic server, we call it a supervisor, to manage the lifecycle. And these things put together lead to extraordinary reliability. Here's what I mean. So let's talk a little bit about what this OTP thing is about. This is mainly an abstraction for processes that implement services, so you might expect that we call these things servers, and we do. So these servers represent a generic form of service with a common API so that we could customize them ourselves. So we have these things called generic servers. Now, you might be wondering how you might start these. And one way to do so would be to start them directly with your application. But that has a problem. So if the service dies, if the process dies, then the application is left holding this sad little pointer that it doesn't know what to do with. So the application is sad, everybody is sad, and we don't know what to do. But Joe Armstrong knew what to do. He said, what we really need is a level of indirection here. What we really need is the application to call really another gen server, but this gen server is responsible for managing life cycles. It's a process server, if you will. It's a life cycle server that knows how to start and stop things. And it's also a life cycle server that knows how to detect when failure happens. And these are some of the guarantees of the beam that both Elixir and Erlang run on top of. So this is called a supervisor in OTP speak, but we're going to speak of it in terms of lifecycle because really what we're doing is establishing the knowledge of how to start something and how to take it down cleanly. So the supervisor then so the application is responsible for starting the supervisor, and the supervisor is responsible for starting the gen server. And the gen server, remember, is generic. It can be used to implement a game or a web session or an embedded app. It's generic. It has a common API that we could use to do whatever we want to. And so since we have this level of indirection, if this supervisor dies, it isn't really dead. It's mostly dead, right? Because the supervisor can get notified and it can restart the server in the last known good state. And so then the server can be happy and the application can be happy thanks to our angel, the supervisor. And Joe Armstrong is most certainly happy too. Thanks to Joe and the rest of the team that built this great system, to Joe and Robert Verding and Mike and the whole team at Ericsson that's built this software for us. So that's what OTP is about. So that's our tour through OTP. We've done a couple of things here. The first one is that we've used a process to build a generic server that handles all the process machinery that you might need with you. But the second one is a little bit more interesting, I think. We actually built a generic service to manage life cycles, and that's the genius of OTP. So when things fail, we can just say, hey, did you try turning it off again? We could let things crash, just let it crash, which Erlang is famous for, and we can bring it up again in the last known good state. And that's an excellent thing. This is Bruce, and Maggie behind the camera, and the dog on the floor for Gracio Learning.